Okay, in this video we're going to look up some special cases of equations. First we're going to look at equations with no solution and equations with infinite solution. Some examples of these are on the page 16 in that packet. Alright, special case number 1. Let's take a look at this equation. 2x plus 5 is equal to 2x minus 3. Now, before we get into solving it, just think about this for a second. Here we have 2 times some number plus 5, and on the right side we have 2 times the same number, subtract 3. Is there a number where if we multiply by 2 and add 5, we can get the same number, same answer as if we multiply it by 2 and subtract 3? Well, if you think about it, there really isn't, but let's prove it just in case. Since math is a science, we're going to go through the steps and just prove it just in case. Alright, so we're going to separate left and right sides like we always do. Let's combine our like terms. The 2x. Well, we subtract 2x from both sides. Well, the 2x's actually disappear. And we're left with 5 is equal to negative 3. And this is never true. 5 is 5 and negative 3 is negative 3. They can never be equal to each other in this sense. So we say that this equation has no solutions. There is no number that will give us the left side equal to the right side. So we say no solutions for this one. Special case number 2, a little more complicated equation. Still dealing with whole numbers though, but in this case, alright, we have 3 times the quantity x plus 1, subtract 5 is equal to 3x minus 2. And we again want to know what value of x will make the left side equal to the right side. So it might be a little more challenging to think about in your head, but let's go ahead and go through our steps here. Let's distribute, combine like terms, do all the things we've talked about in previous videos. Alright, we distribute to remove parentheses. Alright, now notice we've got 3x there on both sides. We ran into a problem with that in the last case. Let's combine like terms. Let's put the 3 and the minus 5 together. We get minus 2. Oh, let's take a look here. We have the same thing on both sides. Well, what happens if we just continue on and let's combine our like terms again, subtract 3x from both sides, simplify, and we get minus 2 equals minus 2, which, well, that's true. Minus 2 is equal to minus 2. That's always going to be true. So when you get a solution like this one, what we say is there are infinite solutions. Any value for x will work because if you notice, x disappeared from the equation. When we subtracted the 3x, it went away. It was gone from the equation altogether, which means that from the beginning, no matter what number you put in for x, it will not affect the parts to the equation at all. We will always get the same thing on the left side and the right side. So any number will work. You can throw in anything for x, and it will always work, which is different than case number 1, where no number will work. So when you're working with linear equations, linear algebraic equations in this sense, or equations in one variable, these are the types of answers you can get. You can get infinite solutions where any number will work. You can get situations where no number will work, or you can get the more typical ones where you get a single answer, where x is going to be equal to a number, a fraction, whole number, negative number, decimal. It's going to be a number of some kind. But sometimes you get infinite solutions. Any number will work, or sometimes no number will work, as we looked at in special case number 1. All right. Let's look at this one. What's the value of x if we have this situation? Pause the video if you want to take a look, think about it there. We get infinite solutions. If you look at this carefully, negative 3x plus 12x, we switch the order of those terms, we get the same thing on the right side. We would get 12x minus 3 and 12x minus 3. When that happens, it doesn't matter what x is going to be. We're always going to get the same result. All right, another type of case we're going to look at are simple exponential equations. Let's say we have an equation like this. Remember, exponents are a number multiplied to itself a certain number of times, and that exponent, the little power number up there, tells us how many times the number gets multiplied to itself. So in this case, we have k to the second power, sometimes people say k squared, plus 4 is equal to 29. Well, this means k times k. Whatever the k number is, it's multiplied to itself. K times k. So what number times itself plus 4 would equal 29? Well, here's where we can go back to a see and do table. If we have a see and do table, again, ask the question, what's happening to the k? Well, the first thing happening to the k is it's being taken to the second power, and the second thing is we add 4 to it. All right, so we can go backwards. There is a way to go backwards. There are inverse operations. For adding, we would subtract. For second power, we use the square root. This is where square root comes into play. Square root and second power are inverses of each other. Just like plus and minus are inverses of each other, second power and square root are inverses of each other. So let's just follow those steps and see what happens. Subtracting 4 from both sides, the first step in the do table. Simplify and bring down, we get k to the second power equals 25. And now we want to ask what number times itself equals 25. That actually is a nice, turn out to be a nice number. You can pull it off of a multiplication chart if you know it by in your head. You can do that. However, be careful with this. If you didn't, you can always use the square root function on a calculator. And here's what happens when we take the square root of both sides. What number times itself equals 25? Well, we actually get 2 answers. We get positive 5 and negative 5. Most calculators will only give you the positive, or what is also called the principal square root, but there are actually 2 answers because 2 different numbers will actually answer this question. 5 times 5 is 25, but negative 5 times negative 5 is also 25, so both actually will answer the question. When we write it in standard form, typically in algebra or on higher level math, we want to talk about both answers. We write it as a plus minus. We use this plus minus symbol here to show that k is equal to plus or minus 5, so equal to both numbers there. Okay, and we can certainly check. Do both of them work? They sure do. 5 squared plus 4 equals 25 plus 4. Negative 5 squared is equal to also positive 25. We get the same answer with both numbers, so that proves that both numbers, 5 and negative 5, are answers. All right, and I'm going to leave you with these two to figure out. 2b to the third power equals 54, and 5n to the fifth power minus 16 equals 144. Alright, so just like the square root undoes the second power, there are roots that will undo the third power and fifth power and any other power you might have. If you've got a calculator handy, that can help you, or give these a try. I bet you can figure out what these numbers are. I gave you some friendly numbers here. Alright,